Okay. Good morning, everyone. My name is Jerry Yu. I'm with SAIC Innovation Center, and the topic of talk is from Shanghai to Silicon Valley, a journey towards autonomous driving. SAIC is formerly known as Shanghai Motor, and it's a household name in China, but less well known here in the States, mainly because that we don't actually sell whole vehicles here. Let me just play a short video to give people an idea of our company, history, products, and our innovation. Okay. Sometimes the English subtitle is a little bit too small to see. So we started as joint venture with Volkswagen. We made our first vehicle in 1983. And then we formed a joint venture with GM. Our headquarters in Shanghai, China. We are all over the place in China right now. In addition to the joint ventures, we have our own brand, Runway and MG. And recently we entered the UK market. Number is a little bit old. Right now we're making about 7 million cars per year. Okay, so here's the outline of my talk. I will start with introduction of the company, and then I'll talk a little bit about autonomous driving in China in general, and SAIC's strategy to work towards it. After that, I will introduce some of the work here at SAIC Innovation Center in San Jose. I'll share a little bit of my own thought on the trend in autonomous driving, and conclude the talk. So SAIC is, as I said, the largest automaker in China. Our main business are in whole vehicle manufacturing, components. Actually, some of our components are kind of equipped in the cars in the US. Auto trade and service and financing. So just recently, we announced that we sold overall about 7 million vehicles in China last year. Then the year-over-year growth is about 7%. It's already a little bit slowed down, but still a fairly good number. And we kind of dominate the Chinese auto market with about 23% of the market share. Currently rank 41st in the Fortune Global 500 and with a revenue of over $100 billion. So SSE has about 70 brands, as I show some of them here, and we have about 30 vehicle platforms, including sedans, SUVs, trucks, vans, or even commercial vehicles. The joint venture with GM and Volkswagen contribute the most to our sales. They constantly rank #1 and #2, respectively. You can also, so basically you can find familiar brands here in both US and in China, like the Buick and the Chevy, those kind of things. We are also actively promoting our own brand, specifically Rowe and MG. So those are the brands we acquired from UK, and it's growing really fast. We see our passenger, own brand passenger growth over 60% last year. That said, our headquarters in Shanghai, China, but we have manufacturing businesses, plants and factories across the country. Internationally, we have some of the marketing and support services all over the world, but mostly international manufacturing sites are in UK, Thailand, Indonesia, and India. We have our site here in Silicon Valley and also recently opened a site in Israel. Okay, so next I'm going to briefly talk about the development of autonomous driving in China and its related strategies and efforts of SSE. So thanks to the economic growth in the past decades, China's auto market grew significantly. Although it slowed down a little bit in recent years, it is still the largest market in the world. As you can see in this chart here, we sell about 24 million cars in 2016, and much larger than any other countries, including the US. And also for autonomous driving, the recent survey shows that the Chinese customers are generally more willing to accept advanced autonomous driving or ADAS features. So that is good for the people working in this area. We have the market, and we have the customer that like these kind of features. We also expect the autonomous driving to reduce the traffic accidents. Right? China is among the countries that has the most road fatalities. I probably rank second to India. In 2014, this number is a little bit outdated, but general trend is the same. We lost about 34,000 lives in kind of traffic-related accidents. We also expect that autonomous driving can elevate the traffic congestion, or at least make people's life a little bit easier when they're stuck in the traffic, right? So surprisingly, we have many more cities that are even more traffic congested than LA, right? Among the top 10 most kind of traffic congested cities in the world, China has 3 of them in top 10. And LA is not even make to the list, right? So the government of China generally believes that autonomous driving or intelligent vehicle is a critical part of its plan to upgrade the manufacturing sector and then alleviate the pressure on the economy, environment, or the traffic, right? So they published 2 guidance documents. In China's economy, this kind of guidance documents are very powerful because they normally come with some kind of economic incentive, right? In 2015, There is Made in China 2025 by the State Council of the government. And more recently, there is a National Intelligent Vehicle Innovative Development Strategy. It's still a draft, but it shows the general parts and the view from the National Development and Reform Commission. So the idea is that by 2020, the government expects that what they call intelligent car is essentially L1 and above needs to exceed 50% of the new car sales, right? So we will see more and more ADAS-related features are even better. And then related to that, the V2X is something that is being promoted. Expect the coverage of LTE-based, basically 4G-based V2X needs to exceed about 90% of the road. We'll see a little bit more about that, what does that mean to autonomous driving, right? By 2025, it is expected that our independent ADAS system would exceed 60% of new car production, and more advanced internet and V2X-based ADAS needs to exceed about 30% of a new car. It's a little bit vague about what exactly does that mean technically, but we can assume that L2 and probably L3 are more like 30% of new car production. And the effect is that the efficiency of the road needs to improve by about 80%. The road accident rate drop by 80% too. So those are very ambitious goals that we're putting there as a nation. So for SAIC, accordingly, we come up with some key strategies to fulfill such view. Specifically, we have this four focus called electrification, connectivity, intelligence, and sharing. So for the electrification, general idea is that we want to make our car more and more either purely electric or hybrid based. So we want to, we already mastered the kind of solution for EDU, electric driver unit, battery management system, or energy solution system, hybrid control unit. And then we are working towards the connectivity, that is making the car more internet connected, and V2X, the vehicle to infrastructure or vehicle communication available, right? So those are the two directions. We'll feel a little bit more. The intelligence is what is considered to be mostly related to autonomous driving or artificial intelligence in general. And then as a business model, we try to promote more sharing as kind of a service. So this includes two components. One is vehicle sharing, another is ride sharing. So on the electrification side, this year we sold about 60,000 electric vehicles. That is significant growth already compared with last year. We sold only about 28,000, although it's still a big gap from the leader in the current market. I think the leader sold about over 100K electric vehicles. But we have very ambitious target that in 2020, we plan to sell about 600,000 cars, mostly from our joint ventures, and some of them, about 1/3, will be from our own brand. So to prepare for such a mass production of either electric or hybrid cars, we built our joint venture with CATL, Ningde Shidai. So it's probably the second largest battery manufacturer in the world. So our projected kind of a battery capacity production will be 30 gigawatts in 2020. So as a comparison, we can see that in 2020, we have comparable kind of manufacturing power compared with BYD and Tesla. Right? Tesla is still leading there. On the sharing side, we are mainly promoting the kind of sharing of EV vehicles. We own the largest electrical car sharing company in the world, at least in September 2017, called EV Cars. It's very popular in Shanghai and the surrounding areas. So right now we have 1.2 million users, about 5,000 branches you can pick up and return the vehicles. We're serving currently 30 Chinese cities. So expected that in 2020, this number will grow to serve 100 plus cities with 300,000 vehicles, all EVs. So on the connectivity side, in 2016, we rolled out the first, what we call internet vehicles. It's Roadway RX5. This vehicle is featured with kind of a Yun OS Auto. So we can imagine it's a deeply customized Android operating system developed by Banma. It's a joint venture between us and Alibaba. So we show here that the vehicle has a large screen and it has functionality to connect to the internet, and so that a lot of functions can be controlled in a dedicated app called Banma Zhixing. So the important thing is each user is associated with a unique ID so that we can collect data and customize, personalize a lot of service based on the user's behavior. So this product turns out to be a big success for us. In 2017, the total sales of the internet vehicles on the SEC is around 400,000, including several different brands. Also related to connectivity, this is more related to the autonomous driving. Is in June last year, we rolled out our first 5G-based remote driving functionality. This is still an experimental pilot program in collaboration with Huawei and China Mobile. They are also the premium member of 5G. So the idea is that we can leverage this ultra-high bandwidth of 5G to stream multiple video data from the vehicle to a remote control center. And the low latency of the communication also allows us to do real-time control of the vehicle. So for autonomous driving, it means that generally it is possible in the future through 5G that a human can take over the car if there's any emergency occur. So this is big because I attended some event here, and one accident I heard is that this car that's remotely controlled through 4G, and somehow it loses connection and just back up into another car. So V2X definitely is the way to go for autonomous driving, for fully autonomous driving. Okay, so on the autonomous driving effort among ourselves, in 2015, we already rolled out our first concept SUV, the IGS. And then in 2 years later, we did our public road test. We have now a fleet of this kind of vehicles, and it's running, and we already have testing mileage over 40,000 kilometers. To prepare for the L4 and above autonomous driving, we made the strategic investment with Cote. That's one of the few companies that have the capacity, the capability, and also the license to do HD mapping in China. Just a few days ago at CES, Intel also announced our partnership with them. So in the future, we'll roll out more and more advanced ADAS-related feature, very likely use Intel mobile system. Okay, so this is our effort in SEC China. So next, I'm going to talk a little bit about the work at the Innovation Center here. So our center is founded in 2014, although most of the engineering team are built actually last year. We are part of SAIC's Global Research and Development Network. The other centers are in UK and in Israel. The initial idea is to leverage the top talents here in the Valley and innovative platforms here to develop some cutting-edge technologies. So this is our facility. I show some picture here. It's not too far away from our conference site here. It's about 20 minutes drive without traffic. And we have nice office and pretty good garage for us autonomous driving to work on. The mission of SAIC consists of four parts. We try to analyze the emerging and disruptive technologies. We want to foresee those ones and advise our company to kind of work accordingly. And then we want to develop some key technologies by ourselves or through collaboration so that we can expand our IP portfolio. As OEM, we understand the importance of collaboration, so actively seeking such a collaboration with academia and industries. Finally, we have venture capital business here in the Valley, so part of our effort is to evaluate some of the promising startups and recommend for them to invest. So my colleague Lei later will probably talk a little bit more about that. So in terms of R&D areas that we're interested in, autonomous driving is the biggest effort. We'll talk more later. And human-machine interaction and connectivity is another thing that we focus on. And so generally, they work on autonomous driving-related HMI interface, personalization of driving experience, or some kind of conceptual HMI interface. The new energy tech focuses on the battery material, the wireless, and the faster charging. So for autonomous driving technology, we have these areas of interest. First is, so we either choose, for these areas, we either choose to develop of our own, or we try to collaborate or license technologies from other partners. Mapping and localization is the first one. We assume that in the future we'll get HD map from some provider, let's say Cote. We're interested in precisely localize our vehicles, likely within 10 centimeters, by fusing multiple sensors like LiDAR, GPS, MU, visual or view odometry, this kind of thing. So on the perception side, we care about recognizing moving objects, traffic lights, traffic signs, using detection, segmentation, and tracking algorithms. Nowadays, most of our work are deep learning based. Decision-making and planning, this is the area that we're particularly interested in high-level decision-making. For example, how do we handle the car when we are at intersection, at traffic light, those kind of situations. So traditionally, we have been using a policy-based approach, but more and more we are using deep reinforcement learning-based approach. Related to this, simulation is critical for any of those autonomous driving products or development. We need high fidelity of simulations, both for perception and also for decision making, so that we can debug our system before we do road test in public. So this shows some of the efforts we did here at SSE Innovation Center. We still have a very small team, about 15 people. The center all have 50, but we make some progress last year. So in July, we obtained our AD license from the DMV. In August, we did our first public road test at night. It's a very short route, about 2 miles in Fremont. It was pretty exciting. And in November, we did our demo on autonomous parking. So autonomous parking is considered to be the #1 wanted features, ADAS or autonomous driving in Chinese market, because generally the parking is difficult and a lot of drivers not experienced to do that. Okay, so that was the focus of our work last year. So in this year, we plan to do more public road tests in extended areas and diversified vehicle platforms. So last year, we were mostly using our MGG, so that's our gasoline vehicle. And it's a little bit hard for us to control if we ever work on gasoline cars before. And this year, we plan to test more on the electric vehicles. So in terms of collaboration, currently we are expanding our collaboration with different universities, Berkeley, Stanford. I cannot share too much, but generally Michigan and CMU, MIT. We are also seeking industrial partners, startups, to work with us. Another effort of us is to talk with the startups and recommend some promising startups for us VC department to invest in. So these are some of the ones listed as an example. We already made the announcement. Civil Map, Deep Map are the HD Map kind of mapping company. AutoX, the Tron, autonomous driving solution companies. So Metawave is our new generation of radar sensors. Vicarious is more like on the different AI, new alternative AI solution company. So next, I'm going to share a little bit of my thoughts or feelings about autonomous driving recently. So one of the first observation is that the AD platform, computational platform for L2 and L3 seems to be ready for mass production. As Andrew showed here, Intel Mobileye is leading or was leading this market. In their roadmap, they have their IQ3 and IQ4. IQ4 is already being kind of deployed in some of their new vehicles. So they have a complete solution, including both software and hardware. But they are also a little bit more closed in the sense that for OEMs, there's not too much control, but it's readily available. So that's the strength of them. More recently, NVIDIA kind of upgraded the Drive PX system. So the Xavier is their kind of latest products. It's mainly targeted for L2 and L3. So compared with the previous Drive PX2 is much more powerful, also consume much less kind of power. So that's a big thing for OEMs. On the other hand, they also have a system that is targeted at fully autonomous driving, L4 and above. So that is there's not too much technical details on it because they have some generation of GPU that it's supposed to be better than the Volta thing. But it consumes quite a lot of power there. The good thing about the NVIDIA platform seems to be that they're more hardware focused, so the OEMs can generally develop some of their own algorithms on top of it. So if we look at the relationship of the OEMs and tier ones, although current market for the ADAS-related features, Mobileye probably still leading this market, but generally the trend seems to be that more and more people are shifting toward NVIDIA-based system, right? So in L4 and L5, or some advanced L3, we probably will see NVIDIA products more and more. The other players are kind of Qualcomm, which is leading this effort, and startup companies like Horizon. There's also rumors that Tesla is going to build its own AI chip, so that may be a new trend. If it works well, I guess other OEMs will also follow. So in addition to the L2 and L3, which are close to the market, we are interested in also L4 and L5. Many of the startups here focus on this area, right? We see that generally speaking, it has great need for mobility sharing. So this survey here by Deloitte shows that among the new generations, Generation X, that who has took a shared ride, the most people would question their desire or decision to buy a new car. So it's a bad news for the OEMs. But still, according to the projection of McKinsey, the new car market will continue to grow at a slow speed, but mobility sharing will be booming in the next around 15 years. So this is a little bit hard, but we noticed that at CES, Toyota announced that they are going to shift toward our mobility as service provider. That generally could be the trend because in their product, they provide some kind of autonomous driving as functions that allow the users to customize on top of it. So it is possible that L4 and L5, that before it can handle all situations, then, it's very likely it will be rolled out in a shared mobility sharing environment in a restricted area, rather than just running everywhere freely. So it is kind of my personal belief. Another trend is that the sensors are making a lot of progress, especially on the LiDAR. So this is a list of manufacturers by Leifeng, and the LiDAR sensors are essential for the L4 and L5. We see that they have high resolution nowadays, most people greater than 64 lines, long detection range, 200 meters, and reduce the price. Now the Real P16 is only 4,000, right? The fusion of LiDAR and vision is obvious. You do not have to synchronize or calibrate all of them together. The running system are switching to rotating, to mammals, solid state, or even flash, so that they can be used in the car. Before, the mechanical rotating thing is not supposed to work in a vehicle. So on the image sensor side, there's really not too much change, but Optina, onsemi, and Sony, they're making that image sensors are has a flicker mitigation capability so that you can see the traffic boards or the traffic lights much better. And on the radar side, we see the trend of moving from 2D radar to 3D so that you can have both range and velocity. So a lot of work. So basically, if you use computer vision or basic approach, faraway object velocity estimation generally is very hard. For radar, you don't have such a problem. Okay. On the algorithm side, Andrea already talked a little bit about that. I'm personally interested in unsupervised learning. So this is one of the things that in this last year's CVPR, they have a proposed approach to use just a stereo image of a camera without annotation or supervision so that they can do depth estimation. So before those kind of work are normally done through stereo camera. But right now with the DeepNet, we can learn from stereo camera and predict on monocular camera. So the beautiful thing is here, the supervision, we still consider the geometry as kind of a supervision, right? So the supervision are very cheap, right? You do not have to label out of data. Before all the other deep learning-based approach, generally, you have to label the data, fine-tune your model. In this process, it is greatly simplified. So you have left and right image through a CNN, you predict the disparity map, and with the disparity map, you can reconstruct the left, from the left, you reconstruct the right, and from the right, you reconstruct the left. And you compare with you input as ground truth. So that way you can learn this model. So this is more close to how human vision works, right? We generally do not have too much supervision. We use our stereo cameras, the eyes, and also the motion cues, right, to figure out the 3D environment. So these are some of the examples. Cityscape is another pretty good benchmark data set. They have shown that with just a monocular camera, they can do fairly good decimal estimation. Actually, they're leading on performance in this benchmark data set. So another trend is we are evolving from 2D understanding to 3D understanding. So this is related to LiDAR. I won't go into the detail. So this is a recent work from Stanford that they basically combine the visual data and the LiDAR data to do much more precise object detection. So this is a trend in the algorithm side. So I won't go into the details here. To summarize my talk, in the interest of time, as a leading automaker in China, SAIC is well positioned to bring different levels of autonomous driving to our customers. Innovation Center here tries to build advanced autonomous driving technologies through our own development and collaboration with both academia, industry partners, and startups. So we foresee that the new autonomous driving platform and integration solutions from either NVIDIA, Mobileye, or other tier ones will make L2 and L3 features increasingly available in the market in the near future. For the L4 and above, we foresee that it will very likely the first be deployed in a mobility sharing market in a restricted area instead of just going around anywhere freely. Okay, so that's all for my talk.
Thank you, Jerry. Thank you. We do have a question from the audience. You have 2 minutes to answer this question.
Okay.
So the question is basically in the future, if we want to push the mass production autonomous vehicle to the market, being our vehicle manufacturer, what other works we need to do to improve that?
I think generally for manufacturing, there will be a lot of work. It really depends on what kind of autonomous driving features we're trying to roll out. If it is ADAS-related features, L3 and below, that may be a little bit easy for us. There's still a lot of testing and validation need to be done. Security is one thing that we haven't talked about, but it's fairly big. But for fully autonomous, I think for OEMs to accept that and roll that out to customer, to consumer, it will be still a long way to go. Yeah.
Cool. Thank you so much.
Thank you.
So next, let's welcome our third keynote speaker.